So what we're going to do now is I want to go over a couple problems that are on the worksheet that is on Google Classroom. This is the homework that you'll be working. These are using this equation C equals lambda nu. And with these problems, we're working with electromagnetic radiation. So you're always going to be using, for these particular problems, 3 times 10 to the 8th meters per second. So, and one thing I want to point out on this sheet is that there's this box here, which is kind of towards the top of the sheet. And this has a lot of equalities that will be important as you work through the problems. For example, the relationship between nanometers and meters, angstroms and meters, gigahertz and hertz. So you can write in here, this should be hertz. And then megahertz and hertz, and micrometers and meters. So make sure you're referencing these and getting the, if you have frequency, that you're getting that into hertz. If you have wavelength, you're getting it into meters. If you're not given meters, then you're not given hertz. So I want to kind of work through 5 and 8 because both of these will require that you do conversions before you plug it into the equation. So I just want to show you how to kind of work through these problems, and then I want you to work through the rest of the problems. The other thing I want to point out is some of the problems will ask you which region of the spectrum that a particular wavelength or frequency of electromagnetic radiation falls within. Now, this is something that I do not expect you to memorize, but you can reference this spectrum here. If you're given wavelength, you can look at the top, figure out where it falls. If you're given frequency, you can look at the bottom here and figure out where it falls. If it falls between two different regions, do your best to identify what kind of radiation it is. Okay, so let's look at number 5. Number 5 gives you nanometers, and it's asking you to find the frequency. So I want to show you how to approach that. So copy that onto the next page, and that way we can have room here to work this problem. So again, you have wavelength. This is going to be your wavelength. And it's asking you for the frequency. What is the frequency of the light? So this is what you're looking for. So here we have wavelength is equal to 410.5 nanometers. We do not know the frequency. And we do know, just move this, we do know the speed of light. C is equal to 3.00 times 10 to the 8th meters per second. So when you notice we have nanometers, we need to go to the previous page and go to the box, and we see that there's 10 to the 9th nanometers in a meter. So let's go back down to our problem. And so we want to first convert that 410 nanometers into meters. So we have 410.5 nanometers over 1. Since we have nanometers here, remember we're using conversion factors. To get rid of nanometers, we had to put that on the bottom. We have meters on the top. Now remember, meters is larger, that's going to have the 1, and there's 10 to the 9th nanometers in a meter. So let's plug that into our calculator, and we get 4.105 times 10 to the negative 7th meters. Now this is a definition here, so we're using the significant figures from our number that the measurement given to us in the problem, 410.5. So that will also have 4 significant figures. So now that we have our wavelength in meters, we're now going to plug it into the equation. So we have C is equal to lambda nu. We have 3 times 10 to the 8th meters per second is equal to our wavelength. So we're going to put in 4.105 times 10 to the negative 7th meters times our frequency. And now we're going to solve for frequency. Now, when you plug this into your calculator, it is critical, since you're dividing, that you put that 4.105 times 10 to the negative 7th meters in parentheses in your calculator. So we have 3 times 10 to the 8th divided by 4.105 times 10 to the negative 7th, and we get 7.308 times 10 to the 14th, and that's either 1/2 seconds, or we could write it as hertz, or we could write the unit as s to the -1. Either one of those would be acceptable. Now, the speed of light is also a definition, so we do not worry about the significant figures in the speed of light. Again, the wavelength determines the significant figures for our final answer for our frequency. So if you plug that into your calculator and got a different answer, make sure you kind of work through that. Make sure you know how to plug that into your calculator correctly. Make sure you're using parentheses. So let's go down to number 8. Here we have the wavelength of, we're asked for the wavelength. So that is what we're looking for. What is the wavelength? And it's giving us the frequency. So this is our new. So it's giving us megahertz. So again, we have to go to the previous page and see what the relationship between megahertz and hertz. So we look here, there's 10 to the 6 hertz and a megahertz. So let's go back down. And we're just going to list what we know, what we're looking for. So we have our wavelength, that's unknown. And we have our frequency. So we're going to have to convert this into hertz. So we know that 1 megahertz is 10 to the 6 hertz. So that gives us 99.5 times 10 to the 6 hertz. And then we have our speed of light, 3 times 10 to the 8th meters per second. So now we're going to solve for wavelength. So we have our speed of light equals our wavelength times our frequency. So let's plug things in. So we have 3 times 10 to the 8th meters per second is equal to 99.5 times 10 to the 6 hertz times our wavelength. So again, make sure you're putting this in parentheses when you bring it over to the other side of the equation. So we're going to be dividing the speed of light by the frequency to solve for wavelength. So we have 3 times 10 to the 8th divided by 99.5 times 10 to the 6th in parentheses, and we get a wavelength of 3.02 times, actually it's just 3.02 meters is our wavelength. Now you notice again, speed of light is a definition. We use our frequency to figure out how many significant figures should be in our final answer. Okay, so this is just an example of 2 different problems that are on your homework. So I want you to work through the rest of the problems here. Please email me if you have any questions.